This one comes from the 2018 AMC10B, number 22. X and Y are chosen at random between 0 and 1. What's the probability that X, Y, and 1 are the sides of an obtuse triangle? Let's say you're taking a test and you have 1 minute left for this question. What should you guess, or should you leave it blank? And if you guess, which one would you guess? Anyone have any thoughts? Well, let's. Sorry.
Caden the V10.
Caden?
Yeah.
Okay. What do you want to say?
I think maybe guess, because it's like one of the last 5 problems.
Okay, but like I said, you probably shouldn't guess unless you can eliminate some of the answer choices. Can you eliminate any of them? Okay, let's consider the probability that they even form a triangle at all. This is much simpler because if X, Y, and 1 don't form a triangle, then 1 minus X, 1 minus 1, and 1 do, because this is equivalent to X plus Y less than 1, in which case 2 minus X minus Y is greater than 1. So that means the probability that they form a triangle at all is half, which means the answer should probably be less than half. So we can eliminate D and E. This means that we should choose one of A, B, or C. Because we've already eliminated 2 answer choices. As a quick note, sometimes you also want to put yourself in the test maker's mindset. Why would they have 0.79 as an answer, for example? If you think about it, these two differ by exactly 0.5, and that's the probability we calculated for them not forming a triangle. So the test makers probably put this answer in just to hope someone would accidentally put it and forget to subtract the 0.5 probability that they don't form a triangle at all. So if you can see that, that's good, but keep in mind that doesn't always work, and usually it won't. So just a quick note, though, can be helpful. Yeah, the correct answer is C, by the way. Are there any questions about that? Okay, I'll move on. Here's another example for, oh, I guess I had the solution written down. I didn't even notice. Whoops. Okay, let's try this one. Let n be the least positive integer greater than 1000, for which these two are satisfied. What's the sum of the digits of n? Same conditions, 1 minute. What would you do? Anyone have any thoughts on what they would want to do? Yeah, Kaden? Or are you gonna say something?
Yeah.
Okay. What would you say?
Maybe like kind of test out the first and the last numbers, so then you can find like to see like where is like the ranging in between.
Okay, but notice how it asks for a sum of the digits. It doesn't ask for n itself. So how would you test 12, for example?
Like you insert that into the places of n. So like it would be like if the common denominator of 63 and 132 is 21, then it would be that. So
Okay, but the problem is just if we tried to test this, just try to test 12.
Fine.
There-
Like, if you test 12, because the sum might be the same, because like 12 and 21 both have the same sums. So if 12 is like one possible answer, that means 21 is another possible answer.
Oh yeah, you see, the problem is that like there's a lot of numbers that have their digits summed to 12. You can't really test 12 because you can't really test all the numbers with digits summing to 12. That'd take too long.
Oh, okay.
What I'm trying to get at here, you should probably leave this problem blank because I think I've explained that on the next as well. N, yeah, you don't really have any bounds on n except it's greater than 1000. If you could find a rough range, the sum of the digits, like the sum of the digits can vary widely. Say from 1099 to 1100, the sum of their digits differs by 17, even though they only differ by 1. So there's really no way for you to guess what the sum of the digits is. You should probably leave it blank. The only thing you have to go off of is since n plus 63 is divisible by 60, for example, n must also be divisible by 3 because 63 and 60 are divisible by 3. But that's not helpful because all of these answer choices are divisible by 3. So yeah, you might as well just leave it blank. Does that make sense? Oh, there's something in the chat. Oops. Yeah, okay.
Yeah, I'll watch the chat and answer the chat. So
Okay.
you don't need to worry about it, Derek.
Okay. Let's see, what was next? Test structure. So there tends to be a lot of algebra, some combinatorics and geometry. Number theory isn't as big in the test, but it's also important. I would consider difficulties like 1 through 10 are easy, 11 through 20 are medium, 21 through 25 are hard, though these ranges are very broad. And as I've mentioned before, sometimes a problem can be misplaced and be very easy or very hard within its range. So we'll be seeing some examples of easy and medium problems of each subject. Here's an easy algebra problem. Assuming A is not 3, B is not 4, C is not 5, what is this expression? Anyone want to answer this? Does anyone want to share how they would do this problem?
I think it'd be a good idea to cancel numbers.
Okay. How would we cancel the numbers here?
Or like cross off 5 and 5. Right.
Well, you see, they're each part of their own expressions. You can't just cancel the 5s.
Oh.
Yeah, feel free to write in the chat.
Yeah.
What do you think the
I'm
answer
asking
is? Or unmute yourself and say your answer.
Okay, William says minus 60. William, do you want to explain how you got that? Kind of guessed. Well, minus 60 isn't one of the answer choices. Keep in mind that when you're guessing, you tend to want to guess one of the answer choices.
Anyone can answer this? This is one of the easier question. So Kaden, raise your hand again. Kaden, you want
Okay, so you can cancel C minus 5 and 5 minus C.
There's cancel these two.
And you can also cancel A minus 3 and 3 minus A.
So Kaden, if you divide a minus 3 by 3 minus a, does that give you 1 or?
-1.
Yes,
Good.
okay.
So you have two negative ones here. And then?
You cancel b minus 4 with 4 minus b.
Yeah. Okay, so you have three negative ones now. And you multiply them together.
Yeah, you get -1.
Yeah. Good. Oh, there's some stuff in the chat. Oh,
Okay.
okay.
So I'll watch the chat. If it's a question that need you to answer, I'll let you know. So yeah, you
Okay.
can focus on the slides. Yeah.
Got it. Let's see. We can move on to the easy combinatorics. How many four-digit positive integers having only even digits are divisible by 5? Anyone want to explain how they would do this problem?
So William picked a 200. Do you want to explain how you come to this answer? Okay. Okay, William did 5 times 4. That's probably not the, okay, it's a random guess. So yeah, Derek, you can go ahead.
Seems awfully silent today, I swear. Usually this class is more talkative. Okay, anyways, I'll explain. So essentially you have 4 digits, right? And each of the digits has to be even. So they have to be somewhere between 0, 2, 4, 6, or 8. Let me write that down. Okay, that's not very neat. The first digit can't be 0 because it wouldn't be a 4-digit number if the first digit was 0. So there's only 4 choices for it. Now the last digit, it has to be even, but it also has to be 0 or 5 because the number is divisible by 5, which means it has to be 0. So there's 4 choices for the first digit, 5 for a second, 5 for a third, and 1 choice for a last digit. This gives us 100 total. Are there any questions about that?
Yeah, this question is pretty straightforward. This is we discussed the similar questions when we were in the first unit.
Yeah, problems like these could appear in the AMC8 as well. Okay, well, let's move on to the easy geometry. Okay, whoops, that did not mean to click there. Easy geometry. This one's a bit of a word problem, but usually easy geometry is really rare. So for how many of the following types of quadrilaterals is there a point in the plane of the quadrilateral? That just means like it's in 2 dimensions. That's equidistant from all 4 vertices. Equidistant means equal distance. Does anyone have any ideas? Now that I think about it, I'm not sure if this one's considered easy. Does anyone want to share how they would do this problem, though? Okay, this one's a bit hard. I'll go over it. So squares and rectangles both have centers, first of all. And these centers are the same distance from all four vertices because it's the midpoint of both diagonals. So a square and a rectangle both work. Now, what about a rhombus? A rhombus is a shape with all four sides equal in length. Let me draw the rhombus bigger here. So a rhombus also has a center, but the problem is these two distances aren't the same. So it's not equidistant from all four vertices. That does not work. Likewise, a parallelogram suffers the same problem. A parallelogram has a center as well, but the center is not equidistant from all four vertices. Now, what about an isosceles trapezoid? This one's probably the most difficult one. Let's consider its line of symmetry. The center has to lie on there. And we can actually find a point on here where the distance from this center to these two vertices is the same. If you know a bit of geometry, that's on the perpendicular bisector here. Does this work as our center? Well, this distance equals this distance here. Now let me mark them in a different color. These two, they're the same distance because by symmetry, this line of symmetry is the perpendicular bisector of these two vertices, the top two vertices. Likewise, these two on the bottom, these two on the bottom are also, why can't I draw right now? That's not good. These two are the same by the same reason. So this point is the same distance from all four vertices because we already know these two are equal. And so, yes, an isosceles trapezoid does work. That gives us the answer as 3. Are there any questions about that? Okay, move on to the easy number theory. How many ordered pairs of integers satisfy this equation? I have the wrong answer choices, don't I? Oh boy, I believe the answer choices were 0, 1, 2, 4, and infinitely many, if I remember correctly. Does anyone have any idea? Class is being awfully silent today. Do I have to pick on someone?
I think you can go ahead. You have a lot of materials prepared. Yeah, so.
Yeah, okay, that's fair. Well, the key point to notice, first of all, x to the 2020, that's a perfect square because the exponent is even. This means that it's not non-negative, which means that y squared must be at most 2y. It can't be greater because then the left-hand side would be greater than the right-hand side. So y squared is at most 2y. What values of y satisfy this? Y equals 0 satisfies this. Y equals 1 satisfies this. Y equals 2 satisfies this. And no other values. You can check -1, 3, neither of them work. And in particular, this is because you want y squared minus 2y is at most 0, which means you want y times y minus 2 at most 0. So you'd want 1 of y and y minus 2 to be negative. Well, so that means y is 0, 1, or 2. And we can check if y equals 0, x to the 2020 is 0, so x equals 0. Same thing for y equals 2, you get x equals 0. When y equals 1, x to the 2020 equals 1. There's two solutions to this, plus or minus 1. Don't forget minus 1. Very easy mistake to make, which means that the answer is 4. Are there any questions about that?
Yeah, as you can see, the AMC 8, you rarely need to use algebra, and now in AMC 10, algebra is embedded in, yeah, algebra can be used in many type of questions, like number theory. This question is related to exponential function and square function. So
And a bunch of bounding and inequalities.
right. So in this second unit, after this strategy class, we will first talk about algebra, and hope that will help you build some foundation for solving this type of questions.
Okay. Anyways, that's all the easy subjects. Let's move on to medium examples. Medium algebra. Real numbers x and y satisfy x plus y is 4 and x, y is minus 2. What's the value of this expression? Does anyone have any ideas how to do this problem? So first idea might be let's try to get rid of this x plus y first, because we know that's 4. What happens if we put these two into a fraction of their own now? Let's combine them. You would get x to the 5 plus y to the 5 over x squared y squared. Now x to the 5 plus y to the 5 would not be easy to find. So that might not have been the best idea. Let's take a step back. What happens if we don't get rid of this x and y first? Let's make it part of our fraction. Which means now the top factors, it factors into x cubed plus y cubed times x squared plus y squared. How can we calculate these? Well, x cubed plus y cubed, we know this is x plus y times x squared plus xy plus y, x squared minus xy plus y squared. X squared plus y squared is x plus y squared minus 2xy, because x plus y squared is x squared plus y squared plus 2xy. This evaluates to, you plugging this in, 4 squared plus 2 times 2, that's 20. Likewise, this we can write as x plus y all squared minus 3xy by the same logic, which is equal to 22. X plus y we're given as 4. So this numerator is 4 times 22 times 20, which let's not expand yet. Now x squared y squared is xy all squared, which is equal to minus 2 squared, that's 4. So you divide by 4. These 4's cancel, you're left with 22 times 20, and that's 440. Give me a sec, my parents are being loud in the background. Okay, any questions?
Yeah, so this one involves some equations that, for example, perfect square, difference of squares, and addition of cubes in algebra. So don't worry if you don't know these equations yet. We will give you a summary of these. Yeah, thank you, Derek, for writing them out. So you will be using these equations a lot throughout your learning about algebra, no matter it's in school or in this class.
Yeah, you'll see a lot of equations like these. They're going to be very important for you to know because they'll show up in all sorts of ways during these tests. And of course, difference of squares you should know as well. I'll just write that one out for good measure. Yeah, those are examples of factorizations you might want to know. They're easily rederived though. Anyways, moving on, medium combinatorics. Let A, B, C, D be an ordered quadruple of not necessarily distinct integers, each of them in the set 0, 1, 2, 3. For how many of these quadruples is AD minus BC odd? Anyone have any ideas for this one? I must admit, this class is being pretty silent today.
Maybe they're all exhausted from the AMCA test. Yeah,
Okay.
feel free to bring up questions or just add a comment, right? Even if you don't have a solution, we can work together to,
Yeah,
let's
feel free to
think loud. Yeah, let's all think loud.
add any ideas you want to add. So William says they are all divisible by 4. Are you saying the answer choices? Yeah, okay. So we know the answer is divisible by 4. In fact, they're all divisible by 16, but... Okay, I should probably give a first step. So if AD minus BC is odd, that means you either have AD as even and BC as odd, or you have AD as odd and BC as even. Now, can you do casework on each of these? Okay, so Caden said it should probably be 4 factorial, but keep in mind that the numbers are not necessarily distinct. 4 factorial is just the number of ways for them to be distinct. So let's try doing casework on each of these. If BC is odd, B and C are both odd. They can both be 1 or 3, so that's 4 cases. Likewise, AD is odd gives you 4 cases. Now what about BC is even? Well, that's the opposite of BC is odd, since there's usually 16 ways to choose B and C, because there's 4 choices for each. You subtract the 4 cases where there, oh, someone said something in chat.
He didn't say 4, so also 4.
Oh, no, because remember, since we have 16 ways and 4 of them have BC odd, 12 of them have BC even. Likewise, 12 of them have AD even. So we add these 2 cases, each of them gives 48. So the answer is 96. Does anyone have, oh, there's a lot of chat activity going on now. Okay, yeah. So are there any questions about that? Okay, moving on. Got a few more problems to go through. Medium geometry. Point is chosen at random within the square in the coordinate plane, whose vertices are these. It's a huge square, essentially. So you have this humongous square with lattice points are points with integer coordinates. So they'll basically form like a sort of square grid. They'll look like sort of like this. I'm not going to draw the rest of them in. That'd take too long. And so what's the probability? So the probability that's within d units of a lattice point, that's 1/2. And what's d to the nearest 10th? Does anyone have any ideas how to start?
Well, Peyton, you want to share what you think? You can unmute yourself.
Maybe like first find out like kind of like how much like area is in this square, so you can find out like how many like points are possible to find in here.
Okay, so you're saying the area of the square, that's just 2020 squared because it has side length 2020. Now I want to find the area that is within d units of a lattice point. Now there's a lot of lattice points, so that might be hard to find. Instead, here's an interesting trick. Try simplifying the problem. If we split this big square into a bunch of unit squares, and we consider the area within each, that is one, let me draw on the other line, so 1 d units away from the square, you get that they're all circles of radius d. So like this, for example. And importantly, you'll notice that each square is identical in this sense, which means it suffices only to consider one of these unit squares because you're tiling this unit square 2020 squared times. So let's just consider one unit square. We have circles with radius d. Now I'm assuming they're not intersecting, and you'll see why in a minute. But the point is, these 4 quarter circles can form a whole circle of radius d. And so the area would be pi d squared.
Wouldn't that be an interior angle?
Which one?
The interior angles and the interior angle sums.
Essentially, they're all 90 degrees. So when you add 4 90 degrees, you get a full circle.
Yeah.
Yeah, okay, so the area is pi d squared out of a total area of, since this is unit square, out of 1. So you get pi d squared is equal to 1/2. So d squared is about 1/2 pi. And now let me explain why I know the circles won't overlap. Because 1/2 pi is less than 1/4, which means that d is less than 1/2, as d squared is less than 1/4. Since they're less than 1/2, these two sum to less than 1, so there's some gap in the middle. That's just a side note. Anyways, we can solve the problem now. 1/2 pi is very close to 0.16 because 2 pi is very close to 6. So d is about the square root of 0.16, which is 0.4. Are there any questions about that?
Okay, then said, wouldn't the equation be d equals 1 over square root of 2?
Well, don't forget there's still a pi. Yeah.
Right.
The area of the circle involves a pi, so you divide by the pi first. So you get 1 over 2 pi instead. Okay. Well, we'll move on to medium number theory. 2020 AMC10B, problem 19. In a certain card game, a player is dealt 10 cards. Number of hands is written like this. This just means like in digit form. The digits are 1, 5, 8, A, where A is some digit, 0, 0, A4, A, A0. And you're asked for what A is. Does anyone have any ideas? Let's first consider what this number equals. As we know, this is 52 choose 10, which is equal to 52 times 51 times, yeah, I should probably use the text tool for this. 8 times 47. Okay, so it's this. And so let's consider the factors of 2 in this number. The numerator, 4, 2, where I'm writing the largest power of 2 that divides each number. Sorry, 16 divides 48. So if you divide through, you get that the number is divisible by 16. That's nice to know. What are the divisibility rules for 16? You don't know that yet, but if it's divisible by 16, that means it's also divisible by 8, which means that the last 3 digits are divisible by, wait, give me a sec. I messed up somewhere? Oh, that's embarrassing. Sorry, let me rewrite that. My handwriting's too messy. These were the numbers we had. You have 2, 4, 2, okay. Sorry, it's divisible by 4, but it's not divisible by 8. That's what I meant. So if it's divisible by 4, the last 2 digits are divisible by 4. A0 is divisible by 4. So that eliminates 3 and 7. It's not divisible by 8. That means that the last 3 digits are not divisible by 8. Well, 440 is 8 times 55. So it's not 4. Now, how do we discern between 2 and 6? That's a good question. Let's do the same trick, except instead of using 2, we use 3s. So let's consider factors of 3 in this number. 3, 3, 9, 9, 3, 3, they all cancel. This means the number is not divisible by 3. Well, the sum of the digits is 1 plus 5 plus 8 plus 4 is 18, plus A appears 4 times. So that's the sum of the digits. This cannot be divisible by 3. Well, 18 plus 4 times 6 is divisible by 3. That's 3 times 14. So it can't be 6. So it must be 2. Are there any questions about that? Yeah, I know these problems are a bit hard. Our goal is to make them not hard over the next few weeks.
Yeah.
Wait, William, by yeah, do you mean you do have a question? Oh, okay. In that case, we have some time to talk about miscellaneous problems, ones that do not fit in any categories. This includes, for example, logic problems, which aren't very common on the AMC, or problems that belong in more than one section. Usually, you'll have something called combinatorial geometry, for example, where you do a counting problem, except it's in a geometric setting. So in the next few slides, here are a few examples. Here's a game theory problem. Bella and Jen play the following game on the closed interval 0 through n. Closed means the endpoints are part of it. So they take turns playing, with Bella going first. Bella can choose a real number in this interval. And then and then on your turn, you have to choose a number that's not within 1 unit from any other number. So like if Bella chooses 3, you can't choose anywhere between 2 and 4. So who wins by optimal strategy? Optimal means playing the best they can. Does anyone have any ideas? Okay, so yeah, game theory is one of these things where you have to learn a bunch of strategies. The key strategy here is what's called symmetry, where you take your closed interval, Bella cuts it straight in half. And so this is n over 2. No one can play anywhere here. N over 2 minus 1 to n over 2 plus 1, inclusive. Now these two remaining intervals, they're just flipped images of each other. So whatever moves, whatever moves Jen performs, say, I should use those in a different color. Let's say Jen moves here, then Bella just flips that over here. And likewise, if Jen plays on the right side, Bella plays a corresponding move on the left side. And this way, Jen has to run out of moves first, because whatever moves Jen makes, Bella can essentially imitate. So Bella always wins. Does that make sense? Okay. Moving on to next one. Here's an example of three-dimensional geometry. This shape is folded into a cone. Right, circular cone. Right just means it's sort of centered, essentially. Like its tip is right above the center of the base. So your resulting image will look something like this. And then you have these two directly above each other. What's the volume of the cone? Anyone have any ideas for this question?
Derek, can you explain what's a lateral surface area? I think the students may need to get more familiar with
lateral surface area, right? That means like this part of the surface area. It's the whole thing except for the base. So basically you'll have like an ice cream cone, except it's upside down. Because an ice cream cone doesn't have the top covered, essentially. The radius is 4, which you can see in the diagram.
I think he was asking like, what does radii mean?
Oh, this radius, I'm not going to tell you where it corresponds to in the cone. That gives what the
Radii is this plural of radius, so that means there's 2.
radii. Yeah, they're both 4 because it's part of a circle. And you have to figure out where they correspond here. Okay, let's do that first. Where does this 4 correspond? Well, you can imagine folding this up, and when you fold it up, you're going to have this point where you glue these 2 radii together. Wherever that is, that seam has a length of 4. So 4 is the length of like this line on the surface. It's not the height, but it's like along the surface of the cone. This is called the slant. Okay, so if that's a slant, that's nice to know, but by the way, Caden, it is not B. Now, let's try to find the radius of the base of the cone. That's going to be a bit harder, but notice that, let me use a different color for this. This circumference part corresponds to this part of the cone. What's the length of this? Well, this is 3/4 of a circle. So the length is 3/4 of the circumference, which is 2 pi times the radius. So the length of the circumference is 6 pi. The radius is 6 pi over 2 pi, that's 3. Okay, now the slant is 4. The radius is 3. If we take a cross section, what's the height? Well, by Pythagorean theorem, it's square root of 7. Now, what's the volume formula for a cone? It's 1/2 of, no, not 1/2, 1/3 of pi r squared h. R squared is 3 squared, h is root 7. You cancel a 3 with this 3 here, you're left with 3 pi root 7. Does that make sense?
Yeah, this is a very interesting question. If you're looking at 3-dimension and 2-dimension, and you go down to a triangle, a right triangle, you find the height, you find, and so you had the radius from the area, from area you find the radius, and you have all the information you need to find the volume now.
Yeah. Really, yeah, the point of 3D geometry is to find the correct cross sections, which are like 2D slices. Well, anyways, next, combinatorial geometry. Rectangular floor is 10 feet wide, 17 feet long, and it's tiled with a bunch of 1-foot square tiles. So it looks something like this, but with more tiles essentially, and they're actually perfectly straight, unlike the slanted lines I'm drawing here. If the bug walks from one corner to the other corner, how many tiles does he pass through? It's like in this smaller example, he passes through 1, 2, 3, 4, 5, 6, 7, 8, but these aren't perfectly square, so that might not even be correct. Anyone have any ideas? Well, the key point here is I'll use the smaller diagram again. This time I'll actually make it perfectly straight so that we can actually do stuff on it. So just imagine this represents a 10 by 17 grid. Naturally, it is 4 by 5, but it'll suffice, I think. So if it's 10 tall, no, sorry, 10 feet wide, you'll have 9 different lines like these red ones I'm going to draw in right here. And if it's 17 feet long, you'll have 16 of these yellow lines. These don't include the edges of the floor, by the way. Each time this bug crosses a line, he enters another tile. So like if we draw the path for this example, you'll see that every time the bug crosses a red or yellow line, he enters another tile. This is a bit off. That is very off, actually. This is what it'll look like. Now the problem is, does he ever pass through 2 of them at the same time? So does he ever pass through a corner? Well, this doesn't happen. Why is this? Because 10 and 17 don't share any factors. So like if it passed through, say, some of these corners where it's A to B, then you'd have to have A over B is 17 over 10, because this ratio would be the same as the ratio between the edges of the rectangle. But then A and B have to be 17 and 10 because that's already in simplest form. So we conclude that the bug passes through one of these lines 9 plus 16, that's 25 times. And since he starts in a square and then enters 25 more squares, the answer is 26. And I should not be using yellow to write. Any questions?
Okay, yeah. So yeah, thank you, Derek, for
We're a bit over time, but I did have one more question. Should we?
Let's talk about it in the next lesson. Yeah, I think there's already a lot of questions for the student to digest.
Yeah.
And this is a very good preview of what to expect for AMC10. So thank you very much.
Mm-hmm.
Excellent introduction. Do you have access to a Google Classroom? You can post your slides there, or you want me to post it?
Not yet. I should join the Google Classroom.
Yeah, so so can you join and post this? You probably want, I remember there was one question you need to change the answer keys, right?
Yeah.
So you can do a little bit modification before you post it.
Yeah, okay, I will do that.
Okay, thank you very much. And everyone, do you have any question, comment?
I have one question.
Go ahead, Kaden.
It's for Derek.
Okay, go ahead.
So on the bug problem, I still don't really get how you got 26.
Okay, so I explained that the bug passes through 9 horizontal lines and 16 vertical lines, right?
Yeah, so and each time it passes through a line, that's one tile it goes to.
Yeah, exactly. So it pretty much changes tile. It enters a new tile 25 times. But the bug also starts in a tile. So it starts in a tile, then crosses 25 lines, which means it enters 25 new tiles. So that's a total of 26.
Okay. Thank you. See you next week.
Yeah.
See you all next week.
Goodbye.
Bye, thank you.
再见。
再见.
Thanks.
Goodbye.